So let's look at topic 3, which is measures of central tendency. So what do we know till now? A quick recap. We know that variables have different characteristics in the sense that they are discrete or continuous, and within discrete we have discrete audible and discrete non-audible, and accordingly they follow different levels of measurement: nominal, ordinal, or interval ratio. We also know that there are techniques to describe statistics which we have used, which we have learned, like rates, ratios, percentages, percentage change. These are all relative frequencies because they are relative to frequency in either one category or to the entire sample size. We know that small f is the symbol for small letter s is the symbol for the frequency in a particular category, and capital letter N is the total sample size. We also know that the difference between an observation, a category, and a variable. Then we also learned a few types of graphs, and depending on the type of variable and the level of measurement. So I hope you realize that by now that it is so critical to understand that what is the type of variable and what is its level of measurement, because that helps you decide which descriptive technique to use. Now let's understand another way to describe the data, which is measures of central tendency. What do measures of central tendency do? Basically what they do is that they reduce a huge array of numbers, into single digits. For instance, when you have as I said, if you collect data on income levels for maybe 1,000 people, so you have this 1,000 numbers, isn't it? Like whatever each person has quoted as his or her income. So, and that doesn't make sense. So that's why we learned those techniques of making them into tables and all that, to put meaning to the data. Another way to put meaning to the data is to reduce all these numbers into single digit numbers. So the three measures of central tendency that we will look at is mode, which is the most common score, the median, which is the middle most observation, and the mean, which is the average or the most typical score in the distribution. The three measures vary in terms of how they define central tendency. Also, again, just like what kind of graph we decide or what kind of table we decide depends on the level of measurement of the variable. What kind of measure of central tendency is most appropriate also depends on the level of measurement of that variable. And all the three measures of central tendency will usually give you a different statistic for the same distribution. We'll be using the word distribution a lot. Basically, distribution means that how the observations are distributed across the categories of a variable. That's what a distribution means. That how the various observations, whatever your sample sizes, is distributed across the various categories of a variable. So, for instance, if your variable is race, and you have 50 people on whom you have collected data. So suppose there are 4 categories of that variable race, like white, black, Asian, and Hispanic. How those 50 people on whom you have collected the data are distributed among those 4 categories. That's a distribution. So only in very special cases will you find that the mean and the median and the mode for a distribution are exactly the same. So mode is the most frequently occurring score, and it is the only measure of central tendency that can be used for nominal level data. So whereas, it is the only measure of central tendency which can be used for nominal level data. Okay, so that's important to know. And what is mode? It is as I said, it is the most frequently occurring category. So mode is the category. It is not the most frequently occurring score. That is not the mode. The mode is the category. So if you have a variable like religious importance, and if the most number of people say that they are somewhat religious, that means somewhat religious category is the modal category. So there is a difference between modal frequency and modal category. Modal category is the category which has the highest frequency. Modal frequency is the frequency which is the highest one. We will be mostly looking at, as I have told you that how you can convert. So for ungrouped data, calculating mode is pretty simple. Whatever is occurring most frequently is the mode. For group data, whichever category has the highest frequency is the mode. So the problem with mode is that even if it is the most frequently occurring number in the distribution, it still may not be representative. That's the problem with mode. So that's a major deficiency of mode. So for instance, if there are 10 people who have taken a test, and if 4 of them get a score of 95 out of 100, and then rest of them, all the rest 6 of them are getting scores between 70 and 60, somewhere between 70 and 60. Somebody gets 70, somebody gets 68, 67. They're all different, but they are between 70 and 60. So the mode will be the highest frequency, which is 95, because 4 students out of 10 have got 95. So, but is that the representative of the distribution? Because if you tell somebody that the mode is 95 in this test, modal frequency score, you'll say, wow, this means that a lot of people have done well. But that's not the case, because there are 6 people who are between 60 and 70. So that's where mode gets misleading. It does not tell you, it does not necessarily represent the typical score. It only gives you the score which is occurring the most often, which may not be typical. It may be, it may not be typical. So in this table, you will find that how, with the level of measurement, and how will you determine mode. For nominal, it is the category with the highest frequency. For ordinal, with non-numerical categories, it is again the category with the highest frequency. And for ordinal with numerical categories or interval ratio, it is it is the most frequently occurring score. So when the distribution is bimodal, you need to report both. When you report the mode, you report the score or the category. In case of unimodal symmetric distributions, which we will be looking at in the chapter on normal curve, which is a bell-shaped curve, mode, median, and mean coincide. The advantages of mode is that it's very easy to figure out. Most of the times there's no computation required. It's the only measure appropriate for nominal data. Remember this, is the only measure appropriate for nominal data. The disadvantages is that, of course, it makes only sense for nominal data. Maybe there are distributions where there is no modal category, in the sense there is no highestly occurring frequency, a frequency which occurs the most. And in some distributions, there can be multiple modal categories. And also, as I mentioned before, it may not be representative of the typical score. It may not represent the typical score. Median is the next measure of central tendency. Here, basically, that represents the center of the distribution. So, if you are ordering ordering the categories from highest to lowest or lowest to highest, the middle of that distribution, the observation which corresponds to the middle of the distribution, is the median. And I hope you can now understand that why median cannot be computed for nominal data. Remember, nominal data cannot be ordered. There is no logical order in nominal data. For instance, for a variable like race, there is no logical ordering for the categories. You can say white, black, Asian, Hispanic, or you can say Asian, Hispanic, white, black, or you can say black, white, Asian, Hispanic. It doesn't matter. So that is why median does not make sense for nominal level data, because there is no order to the categories. So median, the way median is calculated is, as I said, it's the middlemost position. And it is, median indicates the position. You first have to figure out what is the position of the median, and then you will figure out what is the value of the median in that middle position. So the first step is to order the scores for ungrouped data. Order the scores from highest to lowest or from lowest to highest. figure out the middlemost position, and then see what score lies in the middlemost position. So when the scores are even, when the scores are odd, what you do is you do n plus 1 divided by 2. So n is the total number of scores. So suppose if we have 7 scores, so it will be 7 plus 1 divided by 2. So the fourth position is the median position. So you have to go back and look at the distribution and see what score is lying on the fourth position. In case where the number of scores are even, you have to apply the same formula, except like suppose if there are 4 scores and you say n plus 1 divided by 2, that becomes 2.5. So it is the 2.5th position. So it is a position which is in the middle of second position and the third position, isn't it? 2.5 is halfway between the second position and the third position. So you have to look at the score which is on the second and the third and add them and divide it by 2. In ordinal level data with non-numerical categories, like this one, like if you have a data on religious importance, the variable is religious importance. The categories are very, somewhat, not very, not at all. So what you will do is that you will look at the frequency, and then how do you determine which is the middlemost position here? In this case, you will not do n plus 1 divided by 2, but you will do n divided by 2. So what you will do is that you will first calculate the cumulative frequency, because that tells you the frequency not just in that category but the previous category too. So you will do n divided by 2. Here the total n is 2970. So you will look at n divided by 2, and then you will figure out in which cumulative frequency category is that n divided by 2, because that is the middlemost, that is the center of the distribution, that is the middlemost observation. And in this case, you will find it in the somewhat category, because 1485th position is the middle position. So this is how you only find the median category because it's non-numerical. It's the categories are non-numerical. So you can't actually find the median value. You can only find the median category. How do you interpret median? It's very important first to compute the statistics. It's equally important to interpret it. How do you interpret the median? So basically, when we rank the observations according to the scores, half of the sample is below the median and half of the sample is above the median for the scores on that variable. That's what median means. So when we rank the observations according to the scores, half of the sample is below the median and half of the sample is above the median for the scores on that variable. So median is the middlemost position. Similarly, we can come up with other kinds of positions in the distribution. What if we are interested in, so median is the middlemost, which is the half. What if we are interested in 1/10 of the, position in the 1/10 of the distribution, or 1/4 of the distribution, or 1/5 of the distribution? So those are known as deciles, quintiles, quartiles. So deciles divide the distribution into tenths, quintiles into 1/5, and quartiles into quarter. So the first let's first understand what is a percentile. So a percentile is the outcome or the score below which a given percentage of observations fall. So for instance, I'm sure you have come across this in standardized tests. They will always tell you, if you are told that you are in the 80th percentile, what does that mean? That means that people who have taken the test with you, if there are 100 people who have taken the test with you, 80 of them have scored lower than what you have, and 20 of them have scored more than what you have if you are on the 80th percentile. This is the concept related to cumulative. It just does not tell you how you have done, but it also tells you who is how people have done relative to you, the people who you have taken the test with. So the first quartile will be the 25th percentile, because each percentile is each number there, so if there are 100 from 1 to 100, so each percentile is like 1, 2, 3, 4, 5, 6, so first quartile is the it's the 25th percentile. The second quartile is the 50th percentile, which is also the median because it's the middle of the distribution. The third quartile is the 75th percentile. Similarly, in quintile, the first quintile is the 20th percentile. The second quintile is the 40th one. The third one is the 60th percentile. The fourth one is the 80th percentile. Similarly for deciles. So what is the, to be clear again about this concept of percentile, because percentile just doesn't tell you that how you have done, but how you have done relative to others. It's a relative concept, it tells you in a relative way. So what is the difference between the two statements, that Rachel has scored 85% on the test and Rachel's test score is in the 85th percentile? When the statement is that Rachel has scored 85% on the test, it just tells you that, all she has scored 85 on the test. But when it tells you that she is in the 85th percentile, that means that there are 15% of the people who have scored more than she has, and there are 85% of the students who have scored lower than she has. Does that make sense? The difference between percentage and percentile. So the percentage is just absolute. It just tells the person's performance. It's like the raw frequency, the small f. It tells you the frequency in that category. Whereas the cumulative frequency tells you not only frequency in that category, but also relative to other categories. That is what a percentile does. The next, the measure of central tendency, the last measure of central tendency is mean. And this is the one which is most popular, which is very commonly used. It's called average, and this is the most commonly used measure of central tendency. To calculate it, all you have to do is add the sum of the scores and divide it by the total number of observations. You may recall the symbol sigma, which we did at the beginning. Sigma means sum of all. So it's basically sigma xi over n, where xi is the all the individual scores. So mean is the most, so the mean is not necessarily the most frequent score. What is that? That is mode. Nor it is necessarily the middlemost part of the observation in the distribution, which is measure of, but that is a median. Mean is the most typical score. It is the most typical score. So mean has following properties. The sum of the deviations of each score from the mean will always be 0. This property of the mean is called the center of gravity of the distribution. Basically what it says is the sum of the distances of the observations below the mean equal the sum of the distance of the observations above the mean. Okay, so we'll look at it with an example, and that should clarify what this means. The second property of the mean is that it is affected by every score in the distribution. And that is called the democratic property. So mean is called a democratic measure because it's affected by every score in the distribution. The book lists another property which we will not go into because that's related to regression. So the mean as the center of gravity, the first property, what does that mean? It means that the sum of the deviations from the mean, the sum of the deviations from the mean add up to 0. A very important term now is deviation. We'll be using this a lot in the subsequent chapters. Deviation basically means that how far you are, how far is the individual score from the mean. That's the deviation, okay? So if we take these scores, if we have an ungrouped data of a small sample, 3, 5, 8, 9, and 10 are the scores. The total number of observations is 5. N, because there are 5 scores. We take the mean as, it comes out to be 7. And then we take the deviation. What is the deviation from the mean? How far is the score from the mean? So it is xi minus x bar. Xi is the individual score and x bar is the mean. That's the symbol for the mean which you'll be using for the sample is x bar. So it is 3 minus 7, 5 minus 7, 8 minus 7, 9 minus 7, 10 minus 7. So you look at the sum of the positive deviations, you look at the sum of the negative deviations, it comes out to be 0. That is the first property. It's a center of gravity. So all the deviations, they converge to the mean and they become 0 at the mean. Deviations, not the scores, the deviation from the mean. So think about it as an example like a seesaw, So if on a seesaw, there are two people, one on the left, one on the right. And if both of them are suppose, 100 pounds, what will you see? You'll see that the seesaw is absolutely stable. But if one of them is, 200 pounds and the other one is 50 pounds, what will happen? The seesaw will tilt to the person who's 250 pounds. Doesn't that happen? It's because the center of gravity, it is the center of gravity shifting to that person who has more weight. So that's what happens here in the mean. It is the center of gravity. So all the observations converge there. And mean is affected by every observation. So if you have an observation, which is very high or very low, mean will shift towards that. This is the example, the seesaw example. Mean will shift towards that observation because the center of gravity shifts towards the observations which has a lot of weight. That is why mean is called the democratic measure. It's because it is affected by every observation in the distribution. Another term you need to know is outlier. Outlier is extreme score. So if you have a distribution like 3, 5, 8, 9 and 30, 30 is an outlier. It's an extreme score. Actually, this another way to look at this property of the center of gravity getting shifted towards greater weight and the democratic measure is by looking at weighted and unweighted mean. Suppose that in a course the weights assigned for that course are like, suppose quizzes are 15%, homeworks are 35% and tests are 50%, and the points scored are 45 out of 100 for the quizzes, 35 out of 50 for the homeworks, 200 out of 200 for the tests. If you don't consider the weights, like the quizzes are 15% and homeworks are 35 and 50, the unweighted mean, you just sum up whatever points you have got and divide it by the total number of points, it is 77.14%. But instead of that, if you decide to include the weights, so quizzes are 15% and the student has got 45 out of 100. So if you want to look at it in decimals, the student has scored 0.45 on the quizzes and it's worth 15%. So you multiply it by 15%. Similarly, you do it for homework. Similarly, you do it for the tests. And you see that the student ends up with 82%, which is more than what he or she would have got if you had taken unweighted mean. So if we had taken unweighted mean, the student would have ended up with a C grade. When you consider weighted mean, the student has scored a B grade. Why is this difference? Because as you can see, the tests are 50% worth and the student has done very well. The student has scored 100% on that. So the weight has shifted towards that. Similarly, if the student had done horribly on the tests, much more horribly than what she or he would have done on quizzes and homeworks, their weighted mean would have dropped below the unweighted mean. Do you see how it shifts the weight? So now the question is, like, having taken this course, you should know that what measure of central tendency is most appropriate for what situation. So two considerations come into play there. One is the level of measurement, and the other one is the shape or the form of the data distribution. So when you have the shape of the distribution which is symmetrical, there the mean, median and mode coincide, so it doesn't matter which one you are using. But most scores are not distributed in the symmetric bell-shaped way. Or there are quite a few instances where you will not have the distribution like this. So suppose you have a distribution which has a skewness. So a distribution which is not symmetric or which is not bell-shaped is called a skewed distribution. Suppose you have a distribution where the tail is on the right. That is called positive skewness. And this usually happens with income data. When you collect data of income from people and you want to graph it, you will see that most of the times it is positively skewed. What does that mean? That there are few outliers. There are few people who have a lot of money. So suppose you have a middle class community and someone like Bill Gates or Warren Buffett come in there. What will happen is that there will be a positive skewness because clearly Warren Buffett and Bill Gates are outliers. Second, another type of distribution skewness is the negative one, where the tail is on the left side. So why should this matter, depending on what measure of central tendency we use? You will find that when the distributions are positively skewed, the mean lies to the right of the median. Why does this happen? Because remember, the mean shifts towards the more weight. So again, going back to the income example, suppose you have a middle class community and then you have somebody like Bill Gates walking in there or Warren Buffett. The mean will obviously shift towards Warren Buffett or Bill Gates' income because it's a democratic measure. It includes the income of Bill Gates or Warren Buffett in the calculation. Whereas median does not get affected so much because it's the middle of the distribution. In case of negative skewness, you will find that the median is to the right of the mean. So remember this, that depending on the shape of the distribution, the median is either on the left, the mean is either on the right or mean is either on the left of the distribution. So this means that when the data is symmetrically distributed, like a bell-shaped distribution, it doesn't matter which measure of central tendency you use. But when the data is skewed, either on with the tail on the right or the tail on the left, then it matters which measure of central tendency you use. So when the distribution is skewed, and if you are using ordinal or interval ratio level data, it's always better to report the median than the mean. So for instance, in case of income, you will see that most of the times median income is reported and not mean income because the data is skewed for income. Income data are usually skewed. Earnings data are usually skewed. How will you make out whether there's a positive skew or a negative skew? A quick way to figure that out is just look at the median and the mean. And if the mean is less than the median, then it's a negative skew. If mean is greater than the median, it's positive skew. So when you are given a distribution, calculate the median, calculate the mean, and see which one is less and more. And that's a quick way to know where is the skewness, on the negative side or on the positive side. So mode is the most frequently occurring score or the category with the highest frequency. Median reports the typical observation. Remember that it is the typical observation. It's the observation in the middle of the distribution. Whereas mean reports the most typical score. It indicates the center of gravity of the distribution. So which measures of central tendency you should use? The table here should tell you which measure of central tendency is to be used in what circumstance. So by now you should know the purposes of 3 measures of central tendency, the definition, the properties and differences, like how the compare and contrast, and how to calculate and identify the 3 measures, and how to select an appropriate measure of central tendency depending on the level of measurement of the variable and the skewness of the distribution. So this brings us to the end of topic 3. Thank you.